Ever wondered how Spotify knows exactly what you want to hear, or how Zillow predicts your house's price before you even post it? It's not magic, it's machine learning. And in this video, I am going to explain to you not just what machine learning is, but how you can exactly build it on your own. So let's dive in. Hi, I'm Edna. Welcome to my channel. I help other software professionals grow their skills and become more productive by using AI-powered tools and workflows. I've been in the tech for about a decade now, and I have experienced it all: the promotions, a layoff, and also burnout. I never forget that morning when I realized that I had lost access to my bank account. First, I thought, man, I must have finally broken VPN because I have too many tabs open on my web browser. But then Slack messages started coming in, and I realized that I was laid off. That moment made me see my career from a different lens, and it inspired me to create this space for real talk and real growth. I publish videos every week, so make sure to hit that subscribe button so that you won't miss out. Oh, and make sure to stick around until the end because, as usual, I have a little nerdy dad joke for you. If you're brand new to machine learning, make sure to check out my previous video linked over here for introduction. But if you're ready to dive deeper, then let's get to it. Let's start with supervised machine learning. Supervised learning is when your data already has labels on it. It's like when you're studying with flashcards. On one side, you have your question. For example, the price of a feature of a house. And then on the other side, you have the price of that feature of the house. Supervised learning, the models basically see so many of these similar flashcards that it learns how to predict the price, the label of a similar question. Now let's flip the coin. Unsupervised machine learning. It's like when you don't have the answer to the questions on your flashcards. Imagine you're presented with a bunch of information and now you have to try and sort it into pattern or similar groupings. It's like when you're given a pile of Lego pieces and you're gonna try and put them into similar categories, but without knowing what the final model is supposed to look like. Next, we're going to go over the most popular algorithms for each of the supervised and unsupervised machine learning. Let's go over some of the most popular algorithms in supervised machine learning. The first one is linear regression. It's when the model outputs continuous numbers when you give it some input features. An example is when you have a scatter plot of house prices and you draw a straight line through it. And that's how you can predict the home prices of similar sizes. This is exactly what Zillow uses linear regressions to predict home prices, which is what they call zestimates. They basically use a bunch of past sales prices, the square footage of your house, and the location of your house, and a few other parameters, and then they predict how much your house costs today. The next one is logistic regression. It's a statistical model which is used to classify your input into different categories. So it's basically yes or no, true. Is it true or is it false? Is it spam or is it not spam? It's like a bouncer in a nightclub, right? So when you go in, if you're on the list, you're gonna get in, so yes category, and if you're not, you're not gonna get in, so you're in the no categories. But another example is your Gmail. Gmail uses logistic regression to decide if a certain email goes into your inbox or spam. It looks at email features like the sender reputation, certain words, the links that are in that email, and then it decides if an email is worthy of your inbox or it goes into spam folder. If you're enjoying this video so far, I would really appreciate it if you like it, comment, and also share it. Also, if you haven't subscribed to my channel, please hit that subscribe button. I would be forever grateful to you. It really helps the channel to grow, but also to show this content to others who might find it useful. And in return, I promise I will answer all of your comments Yes. And also, I want to share a few pictures of my recent trip to a beach called Port A in Texas. All right. Highly recommend it. So, let's continue, shall we? Next up is decision trees and random forests. Decision trees split data into branches based on some rules like if else statements. And then random forests are when you take a bunch of decision trees and therefore you can make stronger and more robust, less biased decisions. It's like when you're trying to figure out what to eat for dinner. First question you ask is, do I want something hot or cold? Then if you choose hot, then you're like, well, do I want meat or vegetarian? And then you make a decision. Random forest is like asking the same questions from a group of friends and trying to make a decision based on the majority vote. Your credit card company uses random forest in order to predict and see if a transaction is fraud. They use transaction features like time, location, amount, and if enough trees flag it as suspicious, then they decide and block that transaction. Okay, the last one we're going to cover for supervised algorithms is called neural networks. It's basically modeled after your brain. It is layers of nodes, which are called neurons, like your brain, and they recognize really complex relationships in data. They are widely used because they're good at recognizing patterns in images, speech, recognition. When you see a face, you immediately recognize it. You don't measure the width of the nose or spacing between the eyes. You just kind of know. This is exactly how the neural networks work. They layer simple pattern recognitions and they figure out and solve this complex puzzle. In real world, you can think of Instagram. They use neural networks to figure out what is it that you're looking at, the content that you're posting. Is it a dog? Is it a beach? And then based on that, they figure out what content to show you more of. Now, let me show you exactly how to do this step by step. The goal of this is to predict housing prices based on the number of rooms and neighborhood characteristics using the Boston housing dataset. Step one, this is how you set up your environment. Make sure you have Python installed and then open a terminal or command prompt and install Jupyter and required packages. You can use this command that I have on the screen. Step two, you can go ahead and launch the Jupyter notebook and create a new Python 3 notebook. Step three, you're going to go ahead and import libraries that are needed and load the actual data. Go ahead and use what code snippet I have on the screen. Step four, select the features and target. Feel free to use what I have on the screen, or you can also tweak it as you like. Step five, train the model. And lastly, you can predict and visualize. And that's it. You've just built a model that can predict home prices based on the number of rooms and the economic status of the area. Now, let's move on to unsupervised learning. Here are some of the most common unsupervised algorithms used today. K-means clustering. It's when the model takes data and puts them into clusters based on similar features that it finds in them. Imagine if you're running a coffee shop and you're trying to put your customers into groups. So you want to know who is a only weekend shopper, who is a regular, who is a bargain shopper. And you do this based off of how much money they spend every week, how many times they visit you, what do they order. And therefore, before you start, you don't know who's who, but after you have labels for each person. For example, in real world, Spotify groups people into segments based on what they like. For example, if they like workout music, chill music, 90s hip hop, and then shows the same music to each of those groups. Next one up is PCA, Principal Component Analysis. It's when you remove a lot of the variables in your data so that you can focus on the most important one, which makes it easier to also visualize and analyze the data. Imagine you have a long itinerary for your trip and you compress that into a postcard. So basically, you remove all those details about every meal you eat, every bus you take in between your destinations, and therefore you get to a point where you can really only focus on the highlights of the trip. In real world genetics research uses PCA to basically remove thousands of gene expression measurements. And so then the scientists can really hone in and figure out the patterns in certain disease. Right. Next one up is, y'all, the name is long, so I have to read it. It is abbreviated for DBSCAN, stands for Density Based Spatial Clustering of Applications with Noise. Although, don't let the name scare you off. It's fairly easy to understand. This algorithm basically groups the data that are closely packed to each other, and the remaining outliers, it marks them as noise. Imagine you're at a party. This algorithm basically, if it sees a group of people, group of friends standing close to each other chatting, that's like one cluster. And then the person that is on the corner standing alone, that becomes the outlier. In real world, in geospatial analyses, scientists use this algorithm in order to figure out which of the earthquakes are closely coupled with each other and closely located to each other, so that they can figure out the real earthquake zones versus removing the background noise. The last one of the algorithms that we're going to cover for unsupervised learning is called autoencoders. It's basically a type of neural network that learns to take the data and basically compress it into a smaller representation and reconstructs it after that, but by preserving what's really important about that data. Imagine you give a 500-page novel to your friend and ask to summarize it for you. They will come back and have a one-page summary, right? It won't cover every detail of the book, but it will have the main plot, the main idea of the book shared with you. In real world, autoencoders are used in banks to detect fraud. They have learned what normal transaction patterns look like, and that's how they can detect anomalies. For example, when there is a huge spike in spending in somebody's credit card, and that's how they detect fraud. And here is how you can do it yourself. The goal here is to group customers based on annual income and spending scores using the K-means clustering. Step 1, we're going to need to install the required libraries. Feel free to use the command that I have on the screen. Step 2, we're going to have to create sample customer data. Again, feel free to go ahead and copy paste this. And step 3, we're going to just go ahead and run the k-means and visualize and see the clusters. There you go. And that's how you group customers without knowing anything about them ahead of time. If you like this video, I would really appreciate it if you can hit that like button on my video and also make a comment and share it. Also, if you haven't subscribed already, please go ahead and subscribe to my channel. It really helps the channel to grow, but also to show this content to others who might find it useful. And now I leave you, like I always do, with a joke, because life is too short not to laugh. I tried giving my dog Caden unsupervised training. And well, now he groups all of my shoes as his shoe toys. I'm kidding. Caden doesn't do that. Yeah, he's past that chewing season.